Hello everyone, my name's Paul. I work for an Autodesk reseller called Micrographics in Cape Town. We're in the southern hemisphere over here. And today, in response to a query that a client had, I'd like to discuss how you might prepare a DWG file, 3D DWG file, for import into Revit, so you might create a topography from Revit. So, one of the ways in which you could prepare a file is shown within the screen below. I'd like to highlight a few things. First of all, if you do have access to AutoCAD and you have a look at AutoCAD, if you show the UCS icon at the origin, okay, and you draw a line from the origin onto some place within your drawing. Let's just set that property over there. Show the UCS icon. So there's the origin. Y pointing up and X pointing to the right. Now that is a right-hand rectilinear coordinate system, one that we are used to. But note that because we're in the southern hemisphere, looking at the easting and the northing numbers, we are increasing going towards the left, and that this is designated as Y. And then similarly in the X direction, going downwards, we are increasing going down. So basically what they've done is, in South Africa they map X to Y and points towards the bottom. So X would be pointing downwards and Y would be pointing towards the left. Now the result of this is you have to look at the increasing numbers on a southern hemisphere or on a South African survey that looks like this, where it goes from 89 to 89,100, and then recognize that it's increasing positively in the negative direction as our axes are defined at the moment. So X is positive towards the right, but we are now saying that it's going towards the left, increasing positive, and so we have to put this in the negative quadrant. Similarly in the Y direction as well. Note that the DWG is placed with respect to an actual origin, 0, 0, and that the easting and northing lines are actually at a real world distance. So that's in meters, which is written on the screen. So we have to multiply that by 1,000 to get 84,300,000 in the negative direction. So that's 84,300,000 in a negative direction, increasing to negative 84,400 as we go down. And there we can see the value over there. There's the value of 84,400. And in the opposite direction, it goes from 89 million to 89,100,000 millimeters. So the X and the Y are oriented to an origin, which is at the 0 point. This is typically how, so because you work with Revit, or perhaps you don't know Civil 3D or any of the other packages, this might be how you are interacting with another piece of software. In any case, this is then based on a real world orientated north to south, east to west perfectly. So you'll see that the delta values in the X and the Z are 0 on those eastings, and in the northings you'll find the delta Y and the delta Z on that line is 0. So in the XY we are fine, we just understand that we are increasing in the negative direction. We're also working on layers. You'll see that this is on layer survey. The purple line, that's on some other weird layer, and then we've got these contour lines, and they are on layer contours. Right, this is a polyline. So polylines can have an elevation, and the elevation is then the true world elevation, where this one is 1507. There's 1507, and that is in the real world elevation, and that is how we would create the three-dimensional AutoCAD file. So if I orbit this a bit, then you'll see that it is a three-dimensional file. Here we can see that the contours are in 3D. And that's what we'll use to generate the topography. So if you can get your surveyor, or if you yourself can set up a file that looks something like this, that would be perfect for bringing into Revit. Reference to a real world origin with the real distances away from the origin, and then also in the vertical. So unless you are going to work with linked topographies from Civil 3D, the question would now be, and you might know that in Revit you don't want to generate topography far away from the origin. So when we bring this CAD file in, we can link it in as a CAD file. You'll then choose that CAD file, and then we would say bring it in center to center. And what that's going to do is orient the centroid of the CAD file into the centroid of the Revit file. So it's going to appear as if it is kind of in the middle of the file there. Okay, let's just change the view range on this view. I think at most you can go about 2 kilometers into the sky. Alright, so now that we're slicing 2 kilometers above the sky, then we can see what that looks like. And then we would generate our topography directly from this file. Two things that you do is you'd set the easting and the northing first. So you could say coordinates, specify coordinates at point. That would be minus 89,000 and another 000. 89 million. 123, 123. That's in millions, minus 89 million. Okay, and then we can check that against the next one, where we will say report shared coordinates, and there we can see that's minus 89, 100. So that's perfect. We do the same thing in the y direction. Okay, we just specify the coordinates at point. We choose that line there. That's minus 84, 300,000. Alright, and then we just need to generate the topography still, and architecture. Note that this file also is based on the level with the 0 offset, so the elevations are going to be true. And so from the massing and site, we can just generate the topo surface from an import, and then use the contours layer that's got the contours line on them. You can see it's picking them all up, and then accept. So that basically sets the coordinate system for the topography, as well as the topography itself. And then of course from here on you can use this as a container file. You can link the container file into your Revit models, place the container file, move the container file in the X and the Y and the Z direction, and rotate as necessary, and then when it's in place, just acquire the coordinates from the container file, and that will mean that your models will have shared coordinates. But that is how you should look at a CAD file. If you create a CAD file like that, then It's very simple within Revit. Simply bring it in center to center so that it's in the middle of the drawing. So the X and the Y, we're basically lying that it's not far away from the origin. But in the Z direction, in the elevation, we've got the true elevation of that site. So I hope you found this useful. If you need help, you're welcome to contact Micrographics, and enjoy Revit.